Okay, now we are dealing with a distance rate time problem, and we have a total distance of the two flights together. So basically, we're going to have the distance of the flight to Seattle plus the distance of the flight to Boston, adding up to a total distance of 3,124 miles. Well, distance can always be expressed as rate times time. So I'm going to have a rate times time for the first plane, a rate times time for the second plane, and those are going to add up to 3,124. We do not know the speed of the first plane, but we do know that it flew for 5.2 hours. The second plane averaged 44 miles an hour less, so its speed will be represented by r minus 44, and its flight time is 2.5 hours, equaling 3,124 miles. We're going to do a little bit of distribution on the left-hand side, and we will now have 5.2r plus 2.5r minus 110 equals 3,124. We can combine like terms on the left-hand side of the equation, and that will give us 7.7r. And while we're at it, let's add the 110 over to the other side of the equation, and we will have 7.7r is equal to 3,234. Dividing each side by 7.7, we find that r is equal to 420 miles per hour. And the other car, which is flying 44 miles an hour slower, that's a plane, is r minus 44 equal to 376 miles per hour. So the first flight is that of the one going to Seattle, as far as labels are concerned, and the second one is the flight which is going to Boston. In this next problem, we have two different pay structures involving commission. The part A asks us to write a model representing the salary. Okay, salary S is equal to the commission of $25,000 plus 16% of whatever the sales X are. In part B, we're going to do pretty much the same thing. The salary S is going to equal $30,000 plus 15% of whatever the sales are. Moving on to part C, we want to know for what amount of sales will the two jobs result in equal salaries. We will set the answers or the equations from part A and B equal to each other. 25,000 plus 0.16x is equal to 30,000 plus 0.15x. I'm going to bring all the variables to the left-hand side, subtracting the 0.15x off, and I'm going to subtract off 25,000 on each side. This is going to give us 0.01x is equal to 5,000, and multiplying each side by 100 moves the decimal 2 places to the right, and we find that x is equal to 500,000, and I'll put a $ in there also.